Have you ever heard of a S.M.A.R.T compatible hard drive? Most recently, I'm sure if you ever bought a hard drive in the past, you may have seen it mentioned on the packaging that the hard drive was S.M.A.R.T compatible. But what is it? It's been around for 20 years. It hasn't made a lot of headway. You don't even see it promoted or advertised or even mentioned on new computers. Well, I'm Mr. Fix-It, your host on ES Repair, and in this video I'm going to show you what S.M.A.R.T is on hard drives and how you can use it to your benefit. So what do they mean by a S.M.A.R.T compatible hard drive? Well, the acronym stands for Self-Monitoring Analysis Reporting Technology. The technology has been around for 20 years. It was thought to be a tool to predict and warn the users of an impending drive failure. When a problem was detected, the S.M.A.R.T firmware in the hard drive would alert the user through the host software of the problem. The user could then copy the data to another drive before the drive failed and all data was lost. Now, as you can see, this is a typical example of what one of these types of errors would show. You would see the post or the boot up process, and as you can see, it says that the S.M.A.R.T status is bad to back up and replace the software. Now, hard drive failures can be are classified into two categories. You have the predictive failures. These are determined by monitoring the performance of the drive. As the performance of the drive diminishes, the data can be used to predict when the drive will fail. The unpredicted drive failure are the results of sudden mechanical failures. And this does account for 60% of drive failures. Now, the first disk monitoring was developed, or the birth of S.M.A.R.T was developed by IBM in 1992. It was at the time called predictive failure analysis, and it was used to determine if the drive failure was imminent. The earliest version was used in the IBM's AS400 servers, and it was limited to only a binary result, pass or fail. Now, Compaq, who is now HP, Seagate, Quantum, and Connor developed IntelliSafe, which also monitored key factors to predict drive failures and could also communicate to the operating system. Compaq submitted the technology for standardization to the Small Form Factor Committee in 1995, and it was accepted by IBM, Seagate, Quantum, Connor, and Western Digital. Now, Western Digital at the time did not have any kind of failure prediction system. The committee did like the approach of IntelliSafe because of its flexibility. Now, after the joint adoption of the IntelliSafe specification, the technology became known as S.M.A.R.T. Now, S.M.A.R.T did go through three phases. The first version only monitored the drive activities online. This is when the drive is in use. The second phase was when it added the ability to where it would additionally monitor operations while the drive was idle or offline. Now, the final version that was released added failure prevention measures by having S.M.A.R.T relocate data in bad sectors to good sectors. This process is called remapping. Now, there are dozens, even hundreds of parameters that can be monitored to determine if a drive failure is imminent. Now, many of these are vendor specific, meaning that the manufacturer picks and chooses what they want to monitor for the hard drive's health. Now, the parameters can range from read errors to free fall protection counts. Now, this here is a list of some of the important ones that you want to watch. The power on hours is the value of the total count of hours minutes, seconds, depends on the manufacturer, that the drive is in the power on state. Means that this spindle is spinning. The life cycle expectancy of a hard drive in perfect condition, running 24/7, is 5 years, or 43,800 hours. Now, on some of the pre-2005 drives, this value may advance erratically or wrap around. In other words, it may just reset to 0 periodically. Now, another one to keep track is the temperature. Now, temperature is very important because this is the current hard drive's internal temperature in degrees Celsius. The ideal operating temperature for a hard drive is between 25 degrees Celsius or 77 degrees Fahrenheit and 40 degrees Celsius or 104 degrees Fahrenheit. Now, although a hard drive can operate between 41 degrees Celsius or 105 degrees Fahrenheit and 50 degrees Celsius or 122 degrees Fahrenheit, this does require active cooling. Another one to look for is the read error rate. Now, this stores data related to the rate of hardware read errors that occurred when reading data from the disk surface. The raw value has different structures for different vendors and is often not meaningful as a decibel number. However, the lower the number, the better. Another one to look for, the throughput performance. Now, this is, after all, performance of the hard disk drive. If the value of this attribute is decreasing, there is a high probability that there is a problem with the drive. The spin-up time. Now, this refers to the time that it takes from the spindle of your hard drive to spin up to the maximum speed. For instance, most hard drives that's in desktop computers spin at 7,200 RPMs. Laptops spins at 5,400. Now, the spin-up time is the total amount of time that it took to get the spindle at full operational speed. Now, this is measured in milliseconds. Now, the lower the number, this attribute is not used in solid-state drives. Now, and the lower the number, the better. Now, here's some of the things that you do need to look out for. Now, the ones that are marked in red are critical. The ones marked in yellow, they do need to be watched. But the ones in red are very critical. The spin-up retry count. Now, this is a very important parameter. This attribute stores a total count of the spin start attempts to reach operational speed if the first attempt failed. Now, if you see an increase in value in this parameter, this does indicate a problem in the hard disk mechanical subsystem. Now, another one to keep an eye on is the reallocated sectors count. Now, this is very important. If you remember earlier, I mentioned about remapping bad sectors. That's where this comes in. Now, this is a critical one. It's the number of times the drive had to relocate data from a bad sector to a spare sector. This process is known as remapping, as I mentioned earlier. And reallocated sectors are called remaps. Now, this allows a drive with bad sectors to continue operation. However, a drive that has had many reallocations at all is significantly more likely to fail in the near future. So this you do want to keep an eye on. The higher the number, the more problems and the higher the risk the drive can fail. Now, it also affects the performance. As the count of reallocated sectors increase, the read-write speed becomes worse because the drive is forced to seek to the reserved area whenever a remap is accessed. The higher the value, the sooner the drive will fail. Now, another one to keep look out. The current pending sector count. This also is critical. This is a number of unstable sectors waiting to be remapped because of unrecoverable read errors or disk errors. If an unstable sector is sequentially read successfully, the sector is remapped and this value is decreased. Read errors on a sector will not remap the sector immediately since the correct value cannot be read and so the value to remap is not known. But it might become readable later. Instead, the drive's firmware remembers that the sector needs to be remapped and will remap it the next time it's written. However, some drives will not immediately remap such sectors when written. The drive will first attempt to write to the problem sector, and if the write operation is successful, then the sector will be marked good, removing the need to remap the sector. Now, this can be a serious problem, because if such a drive contains marginal sectors that consistently fail over some time has passed following a successful write operation, then the drive will never remap the problem sectors. Another one to watch for is uncorrectable sector count. This is the total count of uncorrectable errors when reading or writing a sector. A rise in this value indicates defects of the disk service and or problems in the mechanical subsystem. Another one to look for is the seek time performance. Now, this is the average performance that it takes for the computer or for the drive to seek information or locate data on the disk the moment it receives the request. It's called the seek time. Now, these are measured in milliseconds. And the lower the milliseconds, the better. Now, if it's decreasing, it is a sign that a problem is in the mechanical system. Now, the command timeout, that's another one. Now, this counts aborted operations due to a hard drive timeout. For instance, if a drive is receiving a command to look for data, and for some reason the drive does not respond in a timely fashion, then this right here will count as a timeout because the drive did not respond. Normally, this attribute value should be equal to 0. If the value is far above 0, then most likely there will be some serious problems with the power supply or issues with oxidized cables or damaged cables. Now, another one that I added on here, which you may not see, is the threshold exceeds condition date. Now, this one you may find on some hard drive S.M.A.R.T reports. Now, this is an estimated date that the drive is expected to fail. The firmware in the drive tracks the rate errors occur and predicts when the drive may fail. Now, if a date appears in the TEC field, the drive has calculated the failure is imminent. At the time, you should consider backing up the data. But keep in mind, the date is only an estimate. Nothing else. The drive may fail before or after the predicted date. Now, some drives, or also in the BIOS or the UEFI, also have S.M.A.R.T tests that you can run. Now, you can find these in the BIOS with the UEFI, and it allows the user to perform a S.M.A.R.T test on the drive to determine if the drive is okay. Now, when your operating system crashes or it seems to be very slow, this could be the reason of those issues. It could be something with the hard drive. Especially if you have a 3, 4, 5-year-old computer, this could be a signal that there may be a problem with the hard drive. Well, you can run these tests. Now, the short test checks the electrical and mechanical performance as well as the read performance of the disk. The electrical test might include a test of the buffer RAM, read-write circuitry test, test of the read-write head elements. Mechanical tests include seeking data tracks by testing the servo, scan small parts of the drive surface areas. These areas are vendor specific, and there is a time limit on this test. Now, it checks the list of the pending sectors that may have read errors, and it usually takes about 2 minutes to run these tests. Now, the long extended test is more thorough of the short test. It scans the entire disk surface with no time limit. Now, it could take several hours because it's going to depend on the capacity of the hard drive. The larger the capacity, the longer this test will take. Now, when you're looking at a S.M.A.R.T report, and I'm going to show you an example of one. This here is an example of a S.M.A.R.T report. As you can see, you have the name of the drive, its current temperature, its health status, and its performance. Now, as you can see on this particular drive, this drive is fairly new. It's not even a year old yet. And as you can see, the health is really well. Now, you're going to see the name of the attribute. You're going to see the threshold limit, its current value, its worst value, and its current health status. Now, you may be wondering if this information is accurate and can it be trusted. The answer is no. S.M.A.R.T has no standards or specifications except at the protocol level, how the data is transmitted to the system. This led to a wide range of interpretation of S.M.A.R.T codes and thresholds. The use of S.M.A.R.T varies a great deal between hard drive manufacturers. Every manufacturer has their own set of rules to determine if the drive is failing. The technology was meant to warn the user of imminent drive failure so they can back up their data before the failure. However, manufacturers use the S.M.A.R.T data to determine the cause of the failure to help build better drives. Now, you can use this information, but it's not that reliable. Because if you look in the raw value, now from experience, that is the thing that you want to look into. If you look at the current and the worst and threshold, as you can see on this computer, it really doesn't make no sense. It looks like as if it's supposed to fail right now. But if you look to the right at the raw value, you can see that there's barely anything written. That's where the true data is written. Now, it's written in hexadecimal, which I will go into some other time. But if you start seeing data written in these fields next to the ones that I've mentioned, then there is a sign that something is going on. Now, you don't have to worry about the power on hours. That just tells you how many hours that the computer has been on. As you can see in the lower left, the power on hours is just over 1,000 hours. So as you can see, this is still a new computer. Now, I do have some of them that's over 20 and 30,000 hours. But you can check on these and get an idea as to what the status of your hard drive is. But keep in mind, the information you find in the raw value section is valuable because it will give you some clues that there is a problem with the hard drive. Now, there are issues with S.M.A.R.T, and this is why you have not seen any advertisements or promotions or anything, and why S.M.A.R.T compatible hard drive is always shown as a footnote. Now, there are problems. One, there are no standards or specifications. There's no industry-wide software or hardware standards for S.M.A.R.T data interchange. A manufacturer only has to monitor one parameter, just one, in order to legally call it a S.M.A.R.T compatible hard drive. Just one. Now, Some SMART-enabled motherboards and related software may not be able to correctly communicate with the SMART firmware in the hard drive using some interfaces. For instance, if you have a hard drive connected to a USB port, like external hard drives, you cannot communicate to the SMART firmware in the hard drive. Even if you're using eSATA, you can't communicate with the SMART failure, so you have no idea if that drive is going to fail. USB, FireWire, eSATA, they cannot send SMART data to the PC. This is what I was referring to. There is no industry standards for SMART. This thing has been around for 20 years and it really hasn't taken off. It's primarily used by manufacturers. Now, even if the operating system like Windows, it may not even be able to see SMART on any hard drive if it's part of a RAID system. Now, some programs require an administrator account to query the hard drive SMART report. Now, the implementation of SMART is only in a handful of drive manufacturers, with only a few aspects being standardized to permit compatibility. These are the issues with SMART. Yes, SMART had good intentions, but as you can see, there are still problems they have to work out. So don't be surprised if you've never heard of it. That's because there's really nothing, it's just pretty much at the manufacturer level. Now, if you do see a SMART error, consider yourself lucky, because most of the times you don't see a SMART error. Now, the technology may not be reliable as you want, but it can provide clues if your drive is starting to fail. So keep that in mind. You can't trust the SMART, you can't rely on SMART to tell you a drive is going to fail, but if you routinely pull its reports when you suspect problems, the report can give you clues, as I've shown you here. Well, this concludes this video. I hope it was informative and explained to you what the SMART compatible hard drive actually means. And hopefully later in the future that they will become a standardization, because the technology would be helpful to let us know if a hard drive is going to fail, so we can take steps into saving our data. But as you can see, there is no standardization, and 60% of drive failures are caused by mechanical and unexpected. Well, I'm your host, Mr. Fix-It. Thank you for watching.